Okay, let's start our class today. As you can see, slide. This is the first lecture on chapter 3, components of microwave system. So, in this chapter, we are going to discuss components, different type of active, passive components used in microwave communication systems. So we'll discuss one by one. Start from directional coupler. We'll go up all the way to oscillators, detectors, mixers, filters, microwave antennas, microwave amplifiers, power dividers, different type of hybrids. All these components we'll discuss one by one in chapter 3. So chapter 3 is microwave components. So students are coming to class. Newcomers. Hello students. Our class today will be chapter 3. We'll start chapter 3, microwave engineering chapter 3, which is microwave components. Components used in microwave communication system will be our chapter 3, which will be a little bit bigger chapter. So we'll try to finish it on time. It's a very important chapter. So what we are going to do in this chapter, we are going to select basic components, active, passive components, devices used in microwave systems. We'll discuss one by one. Now, as you can see here in this microwave relay system, it's a simple example. It's constructed by interconnecting different components. As you can see in the diagram, different type of components connected together by transmission line, and it forms our microwave system here. So now, why we need to discuss each individual components? As you can see on the slide, if you know what individual component in a system does, each component, and if you know how it operates individually, then it's very much easy to understand the overall microwave systems for different applications, radar, satellite, any microwave, telephone relay systems, broadband wireless systems, all these microwave systems. In order to understand, it's very important to understand, to know each individual component in that system, and understand how it operates, each individual components. Then it will be it's very easy to understand the big picture. That's why in this chapter we are going to discuss microwave components one by one. It's a very important chapter. So what we are going to do, how we are going to approach this chapter. So for each component, I will explain its operation, how it operates, what's the applications. We'll see some examples. We'll see different type of technical data sheets for each component. this system, you can see here some, here you can see we have a mixer. Here is another mixer. It's one of the device with commonly used in microwave system. So to understand this overall system, big systems, this microwave relay system, it's very important to understand how this mixer, it's one specific device, how it operates, what's different data sheets, applications, types. If you understand how it works, then it will be easy to understand the overall picture. Similarly, for other components like a filter, here you can see bandpass filter, you can see amplifier here, you can see isolators, circulators. Here we have our microwave antenna. Here we have our transmission line. So so that's why I say it's very important chapter. Chapter 3, microwave components. That's our topic today. So these are some of the components we are going to discuss, cover in this chapter. Here you have the components with their corresponding symbol, electrical symbol for these microwave components. So as I said, for each component, it's very important to understand how it operates, and it's very important to understand its application, types, varieties, specifications, and so on, which makes it easy for you to understand overall microwave communication systems. So that's our main goal, objective of chapter 3, which is microwave components. Okay, so the first component, let's start to see our components. So the first component we are going to discuss this chapter is called directional coupler. Couplers and hybrids, related devices, couplers and hybrids. So we'll start from the directional coupler. We'll discuss different type of directional couplers and different type of hybrids. Okay. There are different types, so we'll discuss each type, different types of couplers and hybrids. But in general, you can say couplers and hybrid components. They are used to combine or used to divide the signals, right? In order to combine two signals from two transmission lines into one, or to split or to divide a signal from one transmission line into two or many, we need devices, right? Components. These components, which are used either to combine signals together or to split or divide signals into different components. Generally, we classify them as couplers and hybrids. So we'll start from coupler first, and we'll go to hybrids. What the applications of so our first device we are going to discuss will be a device called directional coupler. So it has so many applications. This device, directional coupler, you can find it in antenna feeds. I will explain these applications. You can find directional coupler in balancer mixers, you can find it in phase shifters, signal monitoring, automatic level control system. So there's so many applications. This device is not designed for a specific application. We use it for so many applications in microwave systems. Directional, the name is directional coupler. Okay, so this device, what we call it directional coupler, as you can see in this diagram, it is a 4-port device. So it has one port, we call it this input port, where we apply our signal. This is called input port. Okay, this is our input. Here it's input port. Here signal is transmitted from input port to this port number 2. So this is port number 1. This is port number 2, where we connect our cables here. Connect your cable to this device. So here it will be the output, port number 2, which is called a direct port. But in addition to these ports, you can see also 2 additional ports here. This is another output port, and this is also another output port. So totally directional coupler, it is a 4-port device. What are these ports? The first port is called input port, where we apply our signal. And here we have port number 2, which is called the direct port. So if you apply a signal from input port, when you inside the directional coupler, there is a transmission line. It goes all the way from port 1 to port 2 inside the coupler. So signal is transmitted in this transmission line. So let's say this is our first transmission line, TX1. Okay, it's first transmission line. So signal is transmitted from port 1 to port 2. But very close, in close proximity to this transmission line, there is another transmission line here, very close to each other, these 2 transmission lines. So this is the first transmission line, this is the second transmission line, TX2. So TX1 and TX2, they are very close to each other, but they are not physically contact. So if you apply signal at port 1, signal will start to transmit from port 1 to port 2 directly through this transmission line 1, right? But because there is another transmission line which is very close to transmission line 1, they are parallel and very close to each other, the 2 wires, a small amount of signal power coupled or transferred from transmission line 1 to transmission line 2. They are not contact each other, no physical contact between transmission line 1 and 2, but still signal is coupled, just like a transformer. When you see transformer, there are 2 windings, but no contact between the windings. Between the 2 windings, we have either air or other core material. When you apply current, primary current on the first winding, you will get current on the second winding, secondary winding, by magnetic coupling, right? Similarly here, by coupling process, this signal from transmission line 1, small part, will be coupled or transferred to transmission line 2. That's why this device is called coupler. This device is called coupler. As you can see on the name of this device, so it has 2 parts. The first part is Okay, so the first part is coupler. Okay, the second part is directional. We call it directional coupler. So why it's called a coupler? Because uh, because this device, we have two transmission lines very close to each other. Signal will be coupled from transmission line 1 to transmission line 2 by coupling process, not physical transmission. So that's why we call it a coupler. It's called a coupler. So what will happen, just as an example, if you apply 10-watt signal with 10 watt, which is P1 input power, which port? Port number 1. We call it input port here. So port number 2, which is called direct port. It's called direct port. Okay, it's called direct port. Port number 2, P2. So P1 is 10-watt signal applied to port 1. When you say port, is we connect our transmission line, the coaxial cable connected here. So at port 2, we have a signal, right? Signal which is transmitted directly from input to output through the force transmission line, TX1. Let's say 9 watt, right? So 9 watt from input signal, as you can see, it is 10 watt. So 9 watt transmitted directly from port 1 to port 2. What happens to the remaining 1 watt? There is 1 watt signal. So this 1 watt signal, small part of the signal, will be coupled to which transmission line? Transferred from TX1 to TX2. And this goes to port number 3, P3 here. This port number 3 is called coupled port. It's called what? Coupled port. Okay, so look here. We apply signal 10 watt for input port. So signal transmitted directly through transmission line 1, and how much power we get at port number 2? 9 watt, right? Which is called direct transmission. But small part will be transferred from transmission line 1 to another transmission line. We call it TX2, very close to each other. When you open directional coupler, inside you will find two transmission lines very close to each other, two wires. So if you assume the insertion loss, attenuation by this device 0, no attenuation, how much power coupled from transmission line 1 to transmission line 2? It is what? 1 watt. Because 9 watt is transmitted directly from port 1 to port 2, direct transmission. Okay, but small part of the signal is coupled and transmitted in different direction. So here we have P3, 1 watt. 1 watt. So 9 watt transmitted directly, we get it at port 2. 1 watt coupled and divided into, when they will get it at port 3. So here the signal, the input signal divided into 2. Most of the signal power transmitted directly from port 1 to port 2, but small portion coupled and we'll get it in another port, what we call it coupled port, P3, 1 watt. Here we are assuming there is no attenuation in the device. Insertion loss due to the coupler assume, which is lossless device. So 9 watt transmit directly, 1 watt will be coupled. Now, it has so many applications, this device. We'll come to the applications. But why we need to take samples from our signals, just to give you some idea. If you go to the hospital, the doctors will take small sample from our blood to test whether we are sick or not, right? For diagnosis purpose. Similarly, here, our signal is transmitting from port 1 to port 2 directly. This device is used to take a small sample from the main transmission line TX1. Small sample of signal will be coupled into transmission line 2, and we get it the output at port number 3, P31 watt. So this signal, which comes from the input port, now divided into 2 parts. One part goes to the port 3, the remaining goes to port number P2. So this is P1, input power, P2 is direct transmission, P3 is coupled. So if you apply 100 watt here, 100 watt signal, you transmit it here. So this is our TX1, transmission line 1. There is another transmission line here, TX2, right? Now this power transmitted directly at P2. Here in the port P2, we may get 90 watt. Okay, 90 watt power. What will happen to the remaining 10 watts is transferred or coupled from TX1 to TX2 by magnetic coupling. These two cables are not directly connected, no physical contact. Only they are separated by small distance, so signal will be coupled just like a transformer from one cable to another cable. How much in this case? If you assume there is no loss, 100 you apply, 9 transmitted directly, 10 watt coupled. So this signal is divided into 2. That's why we say directional coupler is a device which is used to divide a signal or combine 2 signals together. Okay. So we are discussing, just to revise what we have discussed so far, because there are newcomers for the class. We are started today our chapter 3, very important chapter, where we are going to discuss components, microwave components, different type of microwave components used in different type of applications. So some of the components listed here, we'll discuss each components one by one. So if you ask me what is the purpose of discussing each components, so as you can see in this diagram, this is one example of microwave system, which is microwave relay system for telephone transmission. So here you see this system consists of different components. It consists of filters, band pass filter here. We have a device called circulator here. We have our antenna. We have our tower. This is an amplifier here. Here we have a mixer, down converter, up converter, mixer. So to understand the big picture here, what is microwave system? Microwave can be used for radar, satellite. Microwave can be used for broadband wireless transmissions. So these big microwave systems, to understand it, it's very important to understand each devices and components. If you understand how each device operates one by one, it's very much easy for you to get the big picture. That's our main objective in this chapter. So what we are going to do, we'll take these basic components one by one, active and passive components in microwave system, like filters, microwave filters, mixers, microwave antennas, couplers, hybrid components. All these components we are going to discuss one by one. That is our main objective of this chapter. So we have started. These are the electrical symbols of each component. So we are started first device, very important device called directional coupler. It's called directional coupler. What's its purpose? Its purpose is either to combine two signals into one. If two signals comes from two transmission lines, you can combine them into one cable. Or if one signal comes from one transmission line, you can divide it into two or more. These classes of devices, which are used to combine or to divide a signal, we call them couplers and hybrids. So first we start from coupler device. Next we'll come to hybrid devices. So what is a coupler device? Coupler, the full name, we call it directional coupler. I will explain why we call it directional. Not only coupler, directional coupler. It has, as you can see in the slide, it has so many applications. We use it for antenna feeds, feed lines. We can use it for phase shifters. We use it for monitoring signal, monitoring automatic level control. You will find directional coupler in so many applications. It's a very good device. So our today's topic will be directional coupler. So what is a directional coupler? A device looks like this. Directional coupler, as the name indicates, the first term we have to discuss is coupler. What is coupling means? So when you open a directional coupler, inside there is nothing, only two transmission lines, very small cables going straight parallel. One cable like this, another transmission line like this in parallel. They are very close to each other. Okay, very close to each other, two cables like this. So the first cable, this one here, connected to port number 1. This is our port number 1. Here you connect your cable, your signal here, input signal. This port is called input port. Why we need this device? To divide our signal into two parts, right? So P1 we apply at first transmission line TX1. Okay, TX1. This is our first cable. Okay, which is go all the way straight from port 1 to port 2 here. Okay, so this is our port. This is our port 1. We call it input port. This is port 2. This is our port 2. We connect another cable here. This is our output. You will get your signal here. You apply signal here. the signal will be out here. This port is called direct port. It's called what? Direct port. But here, very close to this cable, transmission line TX1, this is TX1, there is another cable very close to it, which is TX2. So, because these two cables are very close to each other, if you apply a signal, small amount of portion, part of the signal will be transferred from TX1 to TX2, right? As you know, in transformer we have primary winding and we have what? Secondary winding, right? In transformer. So these two, they are not contact. Between the two, there is only air, right? They are not connecting. If you apply primary current here, I1, you get what? Secondary current I2. So signal is transferred from this winding to say this winding without any contact. Why is signal transfer? We call it coupling, magnetic coupling, right? Similarly, in directional coupler, inside we have two transmission lines very close to each other. So if you apply a signal to one wire here, if you apply a signal here, this small part of signal is transferred to the second transmission line because the two cables are in close proximity. That's why this device is called coupler, right? It's called coupler. Now, if you apply a signal here, it is input power P1, our input signal, let's say 10 watt signal apply at this port, we call it input port. This is our output, we call it direct port P2, port 2, which is called what? Direct port, we get 9 watt. Okay, we get 9 watt. As you can see here, this device has 4 ports. The first port is called input port. So if you apply a signal here, signal will be transmitted directly through this cable. So this is our first transmission line. Okay, this is our transmission line from port 1 to port 2. Port 2 is called what? Direct port. So if you apply 10 watt here signal, the first cable, we get 9 watt output here. Okay, signal will be transmitted like this in the first cable. But there is another cable here, which is very close contact with transmission line 1. So some signal will be coupled from what? From transmission line 1 to transmission line 2. And we have here another output. We call it coupled output. Port number 3. How much watt we get? 1 watt power. 1 watt we get it at port 3. 9 watt we get it at port 2. Okay. So when you come to this device, directional coupler, here you see another port, which is our port number 3. It's called coupled port. So if you apply signal here, it's transmitted directly through cable 1 to, you get it output here, 9 watt. What happens to the 1 watt signal? The 1 watt signal will be transferred, coupled to another port. Port number 3, you get P3, 1 watt. Signal is divided into 2. This 10 watt power input signal divided into 2. So one signal you will get it here, 1 watt only. Another signal 9 watt, you will get it directly, transmit direct. This is coupled signal. This is direct transmitted signal. That's why we call it a coupler. Okay. Well, that's why we call it a coupler, directional coupler. As I said, we'll discuss different applications of this device. But to give you an idea, what's this device? Why we need to divide a signal? Let me give you only one application. So if you have transmission signal transmission, signal transmission from port P1 to port P2, right? So we are transmitting a signal from port 1, port 2. This is our input. This is our output, right? So signal is transmitted here. Now, if you need to measure, take measurement from this signal, this is a wire. So what we are going to do, there are two options. You can connect directly your meter here. We bring our meter. It can be power meter, okay? It can be spectrum analyzer to monitor noise level, interference level. We can connect directly our meter to this signal, take signal to your meter and measure. But this is not advisable, okay? We can damage our meter. So instead of this, we connect here a directional coupler. So only small part of the signal will go to what? Most of signal transmitted directly, but small part of signal will go to the meter for measurement purpose, okay, for monitoring purpose, for evaluation, automatic level control. It has so many applications. So when you go to the hospital, as I said, to check whether we are sick or not, they will take only small sample of blood and they will tell us whether we are sick or not. Similarly, from our main RF cable, we take small sample of signal by using what? By using this important device.